In this video, we will be discussing about automata, NFA and DFA, right? So what is automata? An automata means a mathematical machine that reads input symbols and changes states according to rules. So automata is basically a type of a machine or robot that changes its behavior upon input, right? And now we will be discussing about alphabet. So what is alphabet? Alphabet means set of symbol used in language, right? For example, I have a alphabet and the set of symbols for these alphabets are 1 and 0, right? Now, what is a string? A string is sequence of symbols from alphabets, right? From that alphabet, right, that set of symbols, the sequence of those symbols will give me a string, right? For example, this can give me 1 0 1 or 0, right? Now empty string, lambda, it means a string containing no symbol. It is represented by this epsilon, and length of empty string is 0, right? Now what is language? Language is set of strings, right? Language is set of strings, right? Now, for example, I can have language of set of strings that could be 0 1 0 1 1 1 1 0 1. Then finite automata. A finite automata means machine having finite number of states. So what is finite automata? A machine having finite number of states, and a finite automata is of two types, DFA and NFA. So components of finite automata is Q, sigma, rho, Q naught, F. What does each of these means? Q means set of states, set of states. This is input alphabet, and this is transition function, and this is start state. You know this start state, and F is final state, right? State represents current condition of machine, right? State can be Q0, Q1 or Q2. Start state. Start state is where the machine starts, right? Start state जहाँ पे एक मशीन शुरू होता है, right? And final state is accepting state. Now, if machine ends here, after input finishes, it is accepted, right? Now, what is DFA? Deterministic finite automata. It means for every state, for every state and every input symbol, there is exactly one next state, right? Indeterministic finite automata, for every state and for every input symbol, there is only exactly one next state. Now, formal definition is this: transition function, set of states into alphabet implies Q. It means one state plus one input will give one next state, right? Now example, my current state is Q0 and I have input 0. So next state will be Q1, right? And I have current state Q0 and input is 1. So next state will be Q0, right? So there is only one answer possible. This is DFA. Now, properties of DFA are exactly one transition per symbol, no lambda transition, one active state at a time, right? Now, this is representation of DFA. Transition table, tabular form of DFA, right? So, state 0, 1, and this is Q0, initial state, Q1 and Q0, Q1, Q1 and Q2, right? When input is 0, it is Q1 for Q0, and when input is 1, it is Q0. For Q1, when input is 0, it is Q1, and when input is 1, it is Q2, right? You can understand this. A string is accepted if after complete input, machine ends in final state. Suppose Q2 is final and input is 101. If final state reached, it is accepted, right? Now there is an example, a language, a strings ending with 1, right? So I need a language in which strings are ending with 1. So states will be Q0, ends with 0, Q1 ends with 1, so Q1 is final. Transitions will be state, Q0 state, Q1, input 0 and 1, for 0 Q0, for 1 Q1, for 0 Q0 and for 1 Q1. Now testing, input is 101. So for 1, right, from Q0 it will go to Q1, and then for 0 it will go to Q0, and for 1 it will first from Q0, and for 1 it went Q1, and then for Q1 and 0 it went to Q0, and for Q0 for 1 it will go to Q1. So it ends in Q1, right? Hence it is accepted. Now regular language, a language accepted by finite automata is regular language. Patterns used in patterns used to represent regular language are regular expression. For example, A stars, A plus B. Star means 0 or more time, right? Plus means union, and AB, this means concatenation. Now NFA, non-deterministic finite automata. In NFA, one state plus one input can go to multiple states. So in one state plus one input can go to multiple states. Formal definition is rho q into sigma 2 to the power q, which means output is set of states, right? It is set of states. Example, I have a state q0, I have input a, so next state can be q0 or q1. A machine can choose q0 or q1, right? This is what it means. Multiple transitions allowed, may have zero transition, may have lambda transitions, multiple active state possible, right? Now, machine changes state without consuming input. For example, q0 and lambda transition, then q1. Input not read, still state changes, right? Lambda NFA, NFA containing lambda transition, right? Similarly, q0 epsilon, it ends in q1, and then input ends in q2. So machine can jump to q1 freely. What it means? Now epsilon closure, all states reachable from q using only lambda transitions, including q itself. For example, q0 epsilon q1 epsilon q2. Then epsilon closure of q0 is q0 q1 q2, right? It is all the states reachable from q, all the states reachable from q using lambda transitions, right? Now move function qa, states reachable from q using input a, right? What is move function? Move qa, it is states reachable from q using input a. For example, q0 input a ends in q1, then move q0 a will give q1, right? Now trap state, data state, states from which acceptance is impossible, loops forever, right? Trap state. Example, if invalid symbol occurs, machine enters trap state, right? A state from which acceptance impossible, it is looping. Now, what is incomplete DFA? A DFA must have transition state for every state input symbol. Missing transitions are connected to trap state. Incomplete DFA, some transitions are missing and not proper DFA mathematically. Right, equivalent state. Two states behave identically can be merged used in minimization. DFA minimization, reducing number of states without changing language. For example, simple DFA, right? Now, NFA to DFA conversion, right? I am erasing this part. Right. So, what is NFA to DFA conversion? NFA to DFA conversion. Also called subset construction method. main idea. DFA state represents set of NFA states. So DFA state will represent set of NFA states. Now, step 1, take lambda closure of start state. That becomes DFA start state. Step 2, for each DFA state and in each input, find all reachable NFA states. Step 3, take lambda closure again. Step 4, create new DFA state if needed. Step 5, repeat until no state is formed. Step 6, any DFA state containing NFA final state becomes final. Right. So let me show you one example. Suppose I have a given NFA having alphabet of 0, 1 and the states Q0, Q1, start state Q0, final state Q1. Then NFA transition table will be given as state Q0, Q1, input 0 and 1. This can give Q0, Q1. This will give Q0 after taking input 1 Q0 and Q0 for 0 input is 5 lambda and Q1 for 1 input is Q1. So from Q0 on input 0, machine can go to Q1 and Q2 simultaneously. From Q0 on input 1, it can go to Q0. From Q0 on input 0, there will be no transition. From Q1 to input Q1, it will go to, from Q1 on input 1, it will go to Q1, right? Now, one DFA state is equal to set of NFA states and DFA start state is Q0. So, DFA start state becomes, NFA start state is Q0, so DFA start state becomes Q0, right? Because one DFA state is set of NFA states. One DFA state is equal to set of NFA states, right? So transition from Q0, from this is DFA start state, right? NFA start state was Q0, so DFA start state becomes Q0 and this bracket Y, because one DFA state represents set of NFA states, right? So from Q0 and Q1 it can go to Q0 on 0, it can go to Q0, Q1. So row Q0, 0 will give me Q0, Q1. This creates new DFA state Q0, Q1. From Q0 on input 1, it will give me Q0, 1. It will simply give me Q0, right? Set Q0. Now current DFA state. Now process Q0, Q1. So on input 0, from Q0 on 0, Q0, Q1, and from Q1 on 0, it will be 5. So combine both Q0, Q1 union 5 will give me Q0, Q1. So row Q0, Q1 set 0 will give me Q0, Q1. On input 1, from Q0 on 1, it is Q0, and from Q1 on 1, it is Q1. So combining this will give me Q0 union Q1 will give set of Q0 and Q1. So row Q0, Q1 and transition 1 will give me Q0, Q1. So final DFA table will be DFA state 0, 1. This is Q0. On input 0, it is Q0, Q1. On input 1, it is Q0. And then Q0, Q1. On 0, it is Q0, Q1. And on 1, it is Q0, Q1. Right. Now, find final state. NFA final state is Q1 and DFA containing F Q1 becomes final. So, why here I got Q0, Q1? That is because I have to process Q0, Q1. Now, DFA state contains two NFA state, right? DFA state contains two NFA states, so combined transition of both states on input 0 from Q0 on 0 will be Q0, Q1. So from Q1 on 0, it is lambda. So combining both Q0 and Q1 union lambda gave me Q0, Q1. That's why I took here Q0, Q1. And on input 1, Q0 on input 1 gave me Q0 and Q1 on input 1 gave me Q1. So combined Q0 union Q1, it gave me Q0, Q1, right? So this was all for this video. We will discuss next topic in next video.